Hi, everyone. Good morning, good afternoon, good evening, and welcome to another episode of AI Talks.
Hey, my name's Akansha Malik and I'm from Melbourne.
Excellent Sami, Iqbal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Cat. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Alfaka from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Lakita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California.
Hi, Medin Ali Daoud, Greece, Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there. Hi.
Hi. Hi.
Hi.
Hi. Hi.
Hi, everyone. Welcome again. Thanks for joining us on the Global AI Community channel. And just as every week, we have another guest speaker. And today I can welcome Ayodele. Hi, Ayodele.
Hey, everyone. How's it going? I'm Ayodele from the United States. I work for a company called Samba Safety, working on driver risk monitoring.
That's nice. Can you tell a bit more about yourself for people who do not know you at all?
Yeah, absolutely. So oddly enough, I had a really non-traditional path into data science. I did CS for a while in my undergrad, but ended up with a communications degree, worked in marketing for a few years, and that's when I started getting into analytics and advanced analytics. So I did my master's in data science, and I've been working in industry ever since, yeah.
Oh, cool. It's an interesting path from marketing to data science. But actually, if you want to do good marketing, you need to know what the data is saying.
Exactly that. It actually, building some of those data skills actually really helped in marketing.
I can imagine that. What are you going to talk about today?
Yeah, so I'm going to talk about bias in machine learning. This was a topic that was kind of new to me. It really sort of appeared in my work about a year ago. I went to the Data for Black Lives conference, and despite having a master's degree in data science, having taken ethics courses, I didn't have a really firm understanding of what accountability and bias meant as far as coming up with new AI products. So hopefully this will be a little bit enlightening for folks, especially if you're in industry right now.
True. Well, bias is very important. Well, it can really change the way you look at data. So, well, I will just give you the platform and show your screen. Here you go.
So covering bias in ML, I think one of the most important things to do is really set up some of these definitions going forward. As most of us know, like bias has dual meanings as far as society and when we're talking specifically about data science and machine learning. So most people might be familiar with the bias variance trade-off. Understanding in data science, we typically refer to bias as the difference between a model's predicted values and the actual values. In a more narrow view, when we're looking at neural networks, bias term is added to neural networks to avoid issues of randomly setting our weights and our weights are 0 and multiplying by that 0. So it is a term we just add to deal with activation functions in neural networks. But when we talk about bias and its meanings in society, I actually really like this Psychology Today definition. It talks about it as an inclination or a tendency to lean really towards or against something. So a lot of times this can be personal preference, but when that something that we're against is like an entire group of people, typically we're talking about prejudice. So we'll talk about how our algorithms can have bias and in the multiple ways that really shows up. So a couple of these headlines, unfortunately, these are fairly new. I've given this talk about a year ago, and I had a completely different slew of examples. Unfortunately, people tend to trust answers given to us by machine learning without questioning it. And unfortunately, we also tend to have really good insidious use cases for this. So a lot of that is in surveillance and policing, but we'll cover some more of these later and how they show up in particular biases. So one question I like everyone to think about is how you're systemically marginalized. So when people often talk about marginalized groups, they think just like racial minorities, they think gender minorities, but that's not the only kinds of systemic marginalization. So let's say you're from a low income background. Compass, which is a recidivism algorithm used in the United States to help judges predict risk essentially and decide how long of a sentence someone should have. Unfortunately, one of the main inputs to that is did you finish high school? Are you from a low income neighborhood? Do you have friends who are arrested? While these aren't an individual's behaviors, all of those are still part of what predicts their risk. So, thinking about aspects that we're marginalized makes it easier for us to understand and try and fix these problems in our data. Another thing that we have to kind of change our minds on is that data in its core is really not neutral. Um, this is because of a couple reasons, but mostly when the data that we have access to and we're using while we're training machine learning models, it's all influenced by not only how it was collected, who collected it, how it was transformed, how it was maintained. There's so many factors that go into this. And on top of that, the data is always going to be impacted by the societal norms that it was built on. So we're finding a lot of language models have a lot of fairly racist and typically sexist embeddings, but that's because of how our language developed, who is doing most of this writing, who wrote a lot of the text that we did train language machine learning models on. So understanding that makes it easier to build models that are equitable and try to actually create a better balance. So um, it tends to be an invisible enemy sometimes. We have to personally be uncomfortable sometimes with our beliefs to fix some of these problems because everyone has bias. It's not that I don't have bias or there's no blind spots in my perspective. That's not the case at all. But we'll go into a couple of ways this actually gets itself embedded in our technology. So, covering a couple areas of bias that are really impactful in ML. First is prejudice bias. So, let's say you are building a computer vision system to recognize people at work. So, the vast majority of how a lot of these machine learning models are trained are by scraping tons of data off of the internet and trying to create models based off of that. Unfortunately, what we get typically is enforcing a lot of these cultural stereotypes. So, let's say you wanted to build a system, you pulled 2 million images. You're going to see a large skew in those images of men in typically masculine roles and women in typically feminine roles. So, when we think about how to actually change this, the bias can really be reduced typically by introducing a more even distribution of samples. So not only trying to find women in masculine roles, but at the same time consulting with the same people that these models impact. That's a missing step for the vast majority of data science development life cycles is consulting with the people our models impact and not just our direct customers. Another aspect is measurement bias. So, this essentially is when sensors aren't trained or sensors aren't good enough working on these edge cases. And I hate to say, having dark skin is an edge case because it's not. But at the same time, this isn't just heart rate monitors. This isn't just smartwatches. When I fly, I typically take about 5 to 10 minutes longer to go through TSA than the people around me. And that's because the TSA body scanners are not trained on many Black women to begin with, but I have to be patted down almost every single time. One of the main reasons for that is, and there's been like ProPublica articles about this, but these scanners do not recognize black hair and have a really hard time, and unfortunately ended up misidentifying metallic objects in our hair when that's really not the case. So one of the ways to deal with measurement bias is to really widen the pool that we're testing these products on. If we are using dark skin as a benchmark and create products that work for dark skin, it's much more likely that it will also work for people with light skin. But unfortunately, it does not work vice versa. Another major issue we see in machine learning is really sample bias. So unfortunately, it's easy to create systems based off of the data we have, and that data doesn't match what it's going to be like in real life. So a lot of times, especially for facial recognition, our data are things like the IMDb photos. It doesn't seem insidious, but if you think about IMDb, the vast majority of actors in Hollywood are white men. So that model is going to skew towards white men, regardless if that's your training data. The biggest way to fix this is really to stratify your data samples. So this seems simple, but in industry is actually really, really difficult. That means you have to have an understanding of the groups in your data. It may not just be race. It may be zip code. It may be educational background. You have to really have a good grip on the kinds of classes you have to try and balance them out to begin with. Another portion I think that goes in really with that mindset change is that we do have to assume every model is going to is going to encode essentially the racist and sexist norms about essentially around the data it was trained on, unless we address them specifically. It's the same essential concept as garbage in, garbage out. If you have a very biased training set and don't specifically address that in the model process, you're going to have an extremely biased output. It really is essentially that simple, and it's not just the data. It really is how we as practitioners see our perspective as well when we're building and creating frameworks for this modeling. And so that leads directly into our role, essentially. Like I mentioned, bias in, bias out. It's really hard to fix or de-bias some of these systems that have already been created when they've been trained a lot of times on bad data. We also suffer really the curse of setting our own metrics. Like I said, I was in marketing previously, and our metrics were given to us. They were exactly what our customers wanted to see. I wasn't able to choose if I wanted to use, precision, recall, accuracy. I didn't have that choice. Unfortunately, when we're in industry, we're typically under a lot of pressure to meet goals, to build working models within the week, that it's really easy to go with the metric that just looks the best without really taking into account, our false positives, our false negatives, understanding the harm that these models can potentially cause. One of the reasons I think that so many people are interested in data science and machine learning and AI is that we do get to have this really large impact, but we have to understand that it's not always good. Even in my role now, with a lot of my company's clients being places like Uber and Lyft, a model can be responsible for denying someone a job. But in the specific scenario that I'm in, we are a credit reporting agency. So we are beholden to the Fair Credit Reporting Act, which essentially means if someone wanted to dispute a decision, there is a very formal process they go through. We have to legally back up why we made that decision. It could be someone's had their driver's license suspended 4 times in a year, or in the last couple years. Regardless of what that is, we still have to create explainable models and go to our end users and say, here's why this adverse action occurred. But if we compare that to even social media networks, they can run any kind of social, research on their user base without really having to um, stay within some of these like ethical research kind of parameters. So, that being said, we do have to take a bigger role in not only making our models reproducible, but really documenting them well. And that goes a little bit into a couple solutions I have. So, I really hate kind of bringing up these problems without having tangible ways to deal with them, right? And that first step is really documentation. I've been in a lot of data science roles, and the documentation typically around our modeling isn't great. It's hard when we bring new people on, it's hard to understand and update years down the line. But there are a lot of tools that we do have at our disposal. So, for data collection and governance, data sheets for data sets was a really awesome paper that came out of Google. And it goes over ways to track your changes in your data, ways to track the quality of your data. Having these basically in place make it so much easier years down the line. Let's say you implement an accountability process. So let's say you were collecting data about your users, and sometime in the future, you give them the access or you give them the right to revoke your use of that data. Data sheets for all of the data you use for model training would be so helpful in understanding, who has access, what your liabilities around this data are, and really just documenting them in a better way than most people do now, which is typically in a wiki or on someone's personal computer. Uh, and then for model reproducibility as well as risk mitigation, model cards are something that Google actually has a couple examples of for their face detection and object detection algorithms. So, model cards essentially go into outlining some of the limitations of our model. It goes into the performance. It's a really good way to have a quick visual of how your model performs and how well it does. It's a good way to inform stakeholders in your business, not only of that performance, but really of those limitations, ways it can be misused. I found it that it's a really good way to communicate that with people who may have less technical insight on what it's like to create these models on the day to day. On the explainability side of things, there's actually a lot of tools we can use. Shapely values really just give us an insight on the most important features that went into a model creation. Um, I found Lime really, really helpful. So essentially, these are local model explanations that give us in human readable text why, not why a decision was made, but what an explanation for the decision. So, if you're a doctor and you are looking at a healthcare AI, if it was a human in the loop system essentially and used something like Lyme, it would essentially tell the doctor, instead of, the probability of cancer being one is 0.24%, it would say in human readable words, it's most likely not cancerous. And understanding that we need to tailor more of these systems we do create to work with people, so that we don't just kind of as our end users just see these results and see one output and pass that output on because we just believe that computer. But we have to train some of these people working with these systems to see that as one single input into their decision making. Um, a couple other tools here for explainability. One I think is really cool is adversarial ML. So this for computer vision especially is really just people who make these models trying to break their own models. Whether it's an outside consulting team or whether it's done internally, finding some of these deficits is really a lot of the work that we have to do to create models well. Um, Going into best practices, really seeing some of these edge cases as the cases to benchmark against. We've seen multiple scenarios, whether it's a soap dispenser that doesn't recognize dark skin, or whether it's the TSA body scanner or a heart rate monitor. Testing with these edge cases first, or data that you didn't expect to see in the wild first, makes it so much easier to just in general create better projects. And going along with that, really just holding extreme skepticism to our work. I found that one of my best traits is being a skeptic, and very much being willing to challenge some of these results, because we do find issues there. It makes it so much easier to not be married to our work, if we're able to be critical of it as well. And then really just distributing our samples, especially over racial and gender subsets that we know exist, but really taking the next step to um, understand your data and understand where there are classes that you may not have initially thought about. Another area that we, in general, as an industry, need to work on is this human intervention. So we talk about it with autonomous vehicles a lot, going over, what level of autonomy are humans still able to intervene? Um, do we have to have a human intervene? I don't think we should have fully automated AI systems. Um, and I say that because there's always going to be problems, regardless of if self-driving cars reduce just driving deaths. There will still be accidents. If we have more human in the loop systems and have people ready and open, willing to work with machines, we're going to see a lot better solutions that address a lot of these issues that we do see in society. At the same time, humans have an aspect of control. So, going along with this really is about creating open source models and publicly available training data. Um, I say this because unfortunately we have algorithms like Compass in the United States. There are surveillance algorithms that are used by, different police forces that we as the public have absolutely no insight into. We shouldn't have these things be created by private companies. And the reason I say that is because they touch a lot of the public sphere. It's different when Netflix creates a personalization algorithm to get you to watch a different show or movie. That is completely different than housing or a hiring algorithm. There are facial recognition solutions to help you get a job. But if we think about, first of all, the hardware issues with facial recognition, one of the reasons that it's been so controversial is that camera hardware currently really just isn't advanced enough to capture dark skin at the same resolution and with the same quality as it does with light skin. And then you combine that with really bad training data, and you kind of set yourself up for a lot of these problems. So, algorithms that are used to monitor the public are used without essentially the public's consent. These should be available. They should be publicly available. And on top of that, like I mentioned before, really just having a mindset set change around this machine learning development. Most of the way we the way we create these models, there are few steps for really evaluating our data biases. Hardly ever do we do a risk assessment and see what kind of potential harm these models can cause. We have to not see this as just an extension of engineering, but really in a lot of ways of science, like coming up with um, not just like a study, but uh, really having a formal way that we've sampled, that we've surveyed our users, and tracking that in a very formal and organized way is a problem for the vast majority of organizations. And then, like I mentioned before, really just having these uncommon cases as our benchmark, not something that we implement in V2 when we're thinking about machine learning and some of these really large scale products, really. Um, a lot of people are an afterthought, unfortunately. I think it was the Apple Health app was out for about a year and a half. And despite, out of all iPhone users, women making up 51% of users, Apple Health app didn't include something important, which was cycle tracking. So if we want to make better projects or products in general, it's really important to get this feedback from people who are going to be used by it, but also, not neglect some of these people in these like minority classes because we forget or because they're not on the team, or there's an excuse that, there aren't enough resources to deal with that challenge in the first version, and we'll just deal with it in V2 or later. And that kind of takes us into, development priorities. We have to understand most technology was not developed or designed to be representative or work for everyone. What you're looking at now is a Shirley card. It's one of the ways that physical hardware cameras were trained to pick up light skin, to look good, or to make light skin look good. Um, as you can see, it's a very narrow sample that we're looking at, like fair-skinned women. It's not a surprise that we do have so many of the bias issues, especially in facial recognition, because of not just camera hardware, but really how researchers are gathering and sampling their data. So that actually goes into the ACM. So recently, the end of last month, they really just announced that they suggest government and businesses should stop using facial recognition. And for not just the reasons that I mentioned, but typically our use cases for facial recognition are pretty creepy. They're big brothery. It's typically around tracking and surveilling people, um, and in a lot of times they are not aware of this. Facial recognition is used in a number of cities across the U.S. and the world. And if you're out in the public, maybe in the UK, it might be a little different in that these like public cameras have been a little bit more normalized, so people expect that. But in the United States, despite having uh, street light cameras, traffic light cameras, it's really not normalized yet to leave your house and expect to be filmed and expect to have that film be tracked. One of the biggest issues there is we've actually already seen a wrongful arrest because of this. In Michigan, unfortunately, someone was misidentified by a facial recognition system, and police arrested the wrong person. They weren't the person that robbed the store that day, and police really didn't do their diligence to make sure they were looking for the right individual. Instead, they were arrested and had to deal with the entire process of trying to exonerate themselves. And they were arrested only because of a facial recognition algorithm, not because there were other witnesses, not because, it was part of all of the evidence that made this person a suspect, but it was only the algorithmic results. So, that being said, I think it's important to think about how we start new machine learning projects with ethics in mind. So, one, really just questioning if we're creating the right solution for the problem. A lot of times in industry, we don't have the exact data we're looking for, but we use something that's close. Uh, it's it's okay when it's not a super high impact product, but at the same time, we have to try and get the right data or make the decision to pull the plug in some cases. Um, and then, really examining our data for these biased proxies. So, a lot of times people are like, well, I didn't use race or I didn't use gender in my model, but there's a lot of other things that correlate really strongly with race or gender. So, in the United States, zip code. Uh, Having a zip code from a wealthy neighborhood, you're more likely to get approved for a credit card, not because of your own credit worthiness, but because of similar people who live in your zip code. And it works the opposite way as well. Um, if we're talking about gender, one of the biggest correlations is weight. So if you're not using gender in your model, but you're using weight, you can still be encapsulating a lot of the data from gender. One of the things as practitioners we sometimes have to remember is that this data doesn't exist in a vacuum. We are only seeing a couple features of data about an individual person. If we're looking at their medical data, looking at things like their blood rate and their blood pressure, their heart rate, that doesn't give us the full picture. Um, we are always going to be limited to what we have. So we have to develop plans to really mitigate this harm. Um, Many of us are in roles where the worst case scenario isn't too bad or isn't life altering for folks, and it does put us in a position to worry about this a little bit less. But for those of us working really on high impact projects in industries like housing and transportation and healthcare, we have to create plans for what do we do when this model harms someone. What do we do when our user only relied on this model and it was wrong? um, who's the person that they go to complain to? What's that process? How can someone dispute essentially your model's results? And really taking a hard look at who our model is for, and who actually benefits from it, because it's not the case all the time. We often want to be general and say this is for everyone, but genuinely and truly, in most cases, our tech isn't. We're often really exclusionary in ways we don't mean to be. I learned about a year ago that 90% of facial recognition systems don't include or basically exclude trans and non-binary people. There are only male, female, binary classifications for gender in most of these facial recognition APIs that other companies buy and use. So it does have an impact on the kinds of products they build, but we're still encapsulating that narrow gender binary kind of norm on data that doesn't fit that essentially. So testing for bias is a huge aspect that is often left out, but we really need to make more time for. And same goes for giving our models feedback. So algorithms like the recidivism algorithm, they essentially are put out into the world. They are able to predict someone's risk, inform a judge on what kind of sentence that person should get, but they're never given the data back about if that person actually did recommit a crime. So it's important, especially for modeling things like crime. Uh, it's important for these models to get feedback on where they were wrong so they can kind of correct these mistakes. Otherwise, all of the people that they predicted incorrectly on, if those people don't become new training data, the model is just going to think that it's doing the right thing, essentially, and keep propagating this, a lot of these biases into these risk scores. So, with that being said, just a couple more questions for you to think about when you are starting a new project. Really, first is, does this need machine learning? I have been in a lot of cases where we found out we don't actually need to use complicated machine learning tools. And a lot of times it may be a basic linear model or basic statistical model, um, but it is enough to kind of get the results we want without overcomplicating things. And really just thinking about your users. So if this is embedded in an app or if this is a consumer product, how do updates impact users? How do bugs impact users? Are you going to be essentially transparent about how you're using machine learning or AI? Or are you going to run a lot of these models kind of in the shadows and really obfuscated from the people using it? Um, And then, I mentioned giving our models feedback. Another huge part of that is how we collect that feedback. So even for the recidivism algorithm I mentioned, let's say someone was arrested. They go to jail for X amount of years. The algorithm predicts that they will recommit a crime and they don't. How do states and courts, how does this private company that creates Compass get the data that this person wasn't arrested? We have to think about frameworks for this end data collection, as well as how we collect data to really train from the beginning. So spending more time creating those frameworks and building in processes to get new data or to collect data about the actual or the ground truth is really, really important. And it's not that each individual company or data science department has to do that. There are ways to leverage data that other companies have. Let's say it's court records. You can go to your local state or your local government and try and get this information. So it's not always collecting that data yourself, but really taking steps to try and get that data to train and to update our models. And then coming up with a plan essentially to mitigate harm, but also what you do when users are harmed. How you deal with that as a company and as a department, in my mind, really bears more on how you will deal with accountability and transparency at the end of the day. If I see that companies have mitigation plans and risk, it's a lot more believable that they're making fair and equitable models as well. And that is it. Any questions?
Thank you very much for this nice session. So, for all the ones who are watching, if you have any questions, please don't hesitate to ask them right now on chat, and then Ayodele can respond live to you. You can ask a question through YouTube chats, through Twitch, through Facebook, wherever we are streaming to. So, don't hesitate.
Please feel free.
Give them
Yeah.
some time to think about some great questions.
Yeah.
No, I personally also enjoyed your talk.
Thank you.
It's really interesting because if we think about it, it's bias is very dangerous in your data.
Yeah.
And AI is awesome and you can do great stuff with it. But if you're not careful with this kind of things, it makes it again very dangerous.
Exactly.
And yeah, I think it's very important, especially in if you're teaching people about AI, of how it works, that these are one of the main factors you're really focusing on from the beginning onwards. It's not, oh, let's learn deep learning.
Absolutely.
No, let's learn what can happen when you use the wrong data, because it can all go wrong based purely on that.
Absolutely. I think our education systems on data science, machine learning really need an update of really this embedded ethics to understand it from, not just the modeling perspective, but, how we look introspectively as well and say, like I mentioned, I had the blind spot of, when I'm looking at these facial recognition APIs, I didn't even think about people being non-binary. You see male and female, and and if you are in that class, it feels very normal. Every form you fill out just says male, female. You don't think about it. And then when it's like, okay, I should talk to someone else that's not just like me to see how, they would be impacted instead of, me just easily filling out a form and moving on with my day. People feel very conflicted. They are trying to put the most accurate thing that represents them, but they're not really represented. So thinking introspectively has really helped me open my eyes, really, especially when looking at just different classes of data. You don't think typically about age, but that's another huge bucket where we can talk about discrimination. There have been recent articles about this, specifically in the tech industry, and how people feel like once you've reached a certain age, you're too old to invest in, too old to do these things. And so if it's not top of mind, if you're not like in that class that's discriminated against, it's really hard to see.
Yeah, true. Well, we see many big firms that already try to block certain APIs because for certain organizations because they know they could be used wrongly. So that's already a good thing because at the end, yeah, the big firms like a Microsoft and Amazon who are serving this easy to use APIs, they are responsible, so they don't want it to be used in the wrong way.
Exactly.
So that's good. They're already doing that also. But your whole story about bias, it made me think about a TED talk I saw not so long ago by Chimamanda Adichie. She had it's a TED talk about the danger of a single story. Don't know if you've seen it.
I haven't.
Well, it's more about racism, but it was really nice how you could compare it because at the end, what she was telling is that you're as a young person, like if you live in a dark, well, in an African country, the books you get as a kid, they're like with white people inside. And the big
Oh, interesting.
and for us, when we, well, as like long before, when we get books and we learn things about African, it's the bad things we learn. And that creates a bias in our head.
Yeah,
And
absolutely.
it's the same with data. If you only look to data of one side, yeah, you cannot get the full picture. And that's the big danger of it.
And unfortunately, if we, AI for the machine learning, I should say, is really just pattern recognition. And if we understand that, it's not a hard concept to understand exactly what was in that is going to get extrapolated out. And we're typically looking for the signal, but because these are fairly obscure systems, like a single person can't sit down and just understand a model's decision making. We not only capture the signal, but we capture artifacts of the problems as well. We can call them bias, we can call it racism, but it's really just the patterns that were in the data regardless.
Exactly. That's why model explainability is something that really needs to get more people invest in because it's so important. If you cannot tell your customer why your AI model made this decision, well, yeah, then it's tricky.
Problem.
We have a question from Yalda. Yalda is asking, are you able to change the way models are created in your current job? And how difficult is it to get others on board? Very interesting.
That's a good question. I am very lucky I can say yes. I have implemented and spoken to, our data science team is very small. It's myself and a principal data scientist. So we have talked about implementing a lot of these documentation steps and are working on actually being able to having fully fleshed out model cards, having fully fleshed out documentation, having open data in ways that we can. I would say it is in the minority of cases that it's that easy to get other people on board. The other data scientist I work with is really, really passionate about explainability as well. But I would say, especially in larger roles, it takes a little bit of advocacy. I think what has worked best in the past really is showing people that there can be major monetary losses. I was on a diversity and AI panel a couple weeks ago, and a really great quote someone mentioned was, if you spent the last decade of your career working on computer vision and facial recognition at Microsoft or IBM, you can feel like because of the ACM, wanting to ban this technology, you may have thrown away that time. All of your really, really deep expert knowledge was for something that most of tech has now deemed as harmful. So it's hard to be in that position, and you don't ever want to be in that position. But I know that it does take a good bit of advocacy, and if you can show some of these financial losses, it might be easier to get people to change how we start building our models.
money can change everything, as usual.
I always tell people, I'm like, you're just going to lose money and then we'll have to build something different or change it. And they're like, okay, let's just do it right.
Let's do it correctly.
Mm-hmm.
All right. Thank you very much for your time.
Thank you.
We are having another speaker next week also. Then we will have Ivana Tilka, who will be talking about implementing intelligent cross-platform mixed reality apps with Azure Cognitive Services. So if you are in mixed reality and you're in AI, so don't hesitate to connect next week also, same time, same place. So we hope to see you all there then. Thank you all very much for joining us and see you soon again. Bye-bye.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Explainability in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, perpetuate. I come from
I'm
Spain.
Prasant from California.
大家好，我是卢建辉。
My Nederlands. I'm Fantasy from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Ayodele Odubela from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California.
Hi, Ayodele Odubela Africana.
Hi, I'm Ana Falana.
Merhaba, ben Türkiye'den Daronya'dan.
Hi.